Okay, in this presentation we are going to look at the binomial probability distribution. This is a worked example from a CS1B actuarial exam that features the R programming language. It's a short enough one, so we'll move through it fairly quickly. The probability that India will win a cricket match against South Africa is 0.7. Prepare a probability table of the number of wins if India are going to play 10 matches against the South Africans. Plot a bar chart of the probabilities of wins, of the number of wins from 0 to 10, okay, and find the mean and median number of wins for India against South Africa. Okay, so we're going to set this up as a binomial random variable. The number of trials is the number of games that India are playing against South Africa, so that's 10, n equals 10, and the probability of success is p equals 0.7. So there we have there, p is assigned the value 0.7. So what we're going to do is set up the probability distribution table for the number of wins. So the key command here is dbinom. This is the density function essentially for the binomial distribution, although density is not really the right term in this case, but it's essentially the likelihood. The probability of each win from 0 to 10, when there's n trials, size equals 10 and the probability equals 0.7. So the key parameters there are size equals, which is the n value, 10, and p is prob 0.7. So we're going to set them up there, prob, and those are 10 probability values. We're going to set this up as a little data frame called probability densities, and so we have a data frame there, number of successes 0 to 10, okay, that's all the possible outcomes, and then the probability of each possible number of successes, the probability of each of those 11 outcomes, okay. So what we're going to do is set up a little bar chart shortly, but actually there's a couple of interesting little commands related to the bar chart. So I'm going to do one for the probabilities specifically, just to learn a bit more about the bar plot command, which is one thing you can look at here. What I want to do is set up the x-axis labels for the bar chart, and one way you can do it is just actually state names, so then we can actually add names to probability there, the probability density functions, okay? Just name each element in the object. So it's as character 0 to 10. The reason that for that is it becomes a name. So we have bar plot of the probabilities, and main equals binomial probabilities, and LAS is just axis orientation for the labels. So there we have it there, okay? That's just a quick sort of look at the probabilities that we are going to be mapping out. Okay, this is a bit of a digression, but it's sort of interesting. The question does ask us specifically to create a table. So there we have it there. Number of successes, 0 to 10. We have the row index there as well, so that's 1 to 11. You can ignore that. So we have number of successes, 0 to 10, and the probability of each number of successes. And you can sort of see there, it peaks around the number of successes equals 7, but 6 and 8 are also fairly likely, and that's row index 7, 8 and 9, so just disregard the numbers on the left hand side. Okay, so the bar chart of the probabilities, here we go again, and this is just a different way of doing it essentially. So bar plot of probabilities, main equals bar chart of probabilities of successes, xlab equals number of successes, and names.arg equals 0 to 10. So this is just similar enough to what I've done before. It's just actually sort of a compare and contrast, just to sort of see two different approaches. So there we have it there. Number of successes, bar chart of probabilities of success. Now it's very important in these actuarial exams to annotate all your plots thoroughly. Okay, so that's just an important point there. Don't just put in bar plot and prob. Put in the labels and the title as well, as much as you can. That was the motivation for the other approach I showed you earlier on, because if you want to do it a different way. Now, the mean and the median of wins for India against South Africa. Well, the mean is simply 10 times 0.7. This is based on the theory of the binomial distribution. The sample size times the probability gives the mean. In this case, it is 7. That's based on the fundamentals. But you can also define it as a random variable and use that approach there, which is the sum of the sum of each outcome times the probability of that outcome. So this just would sort of work on the basis that you don't remember the theory, basically, is what I'm getting at there. So probability of x is the probabilities, okay, and we have sum of x times the probability of x, which is how we would implement the expectation of a random variable if this random variable is discrete. So we get the same answer there, it's just a slightly different approach. Now, the median. This one's actually tricky, okay? In this case, essentially what you're looking for here is the quantile of 0.5, okay? The 50th percentile. And so here we go, Q binorm, that's Q for quantile, binom. 50% is 0.5, size equals 10, and probability equals 0.7. So that gives us our median, which is 7. And that's it. We'll leave it there.